Good afternoon, everybody. Today I'm going to talk you through terminal velocity. I've drawn a graph here. You can just about see it if I move it up a little bit. I've drawn a quick velocity time graph here. So I've got time down here on the bottom axis. I've got velocity up here on the y-axis. And velocity is very similar to speed, except it has a direction as well. So as you can see, the velocity is increasing for this part of a skydiver's journey. Okay, so right here at the beginning, down in the bottom left-hand corner, I've got a skydiver jumping out of an aeroplane. And as you can see, the velocity is increasing for this skydiver. So I'm going to say velocity is increasing. Now, anywhere we get a change in velocity, we get an acceleration. So the skydiver is accelerating. Okay, so we've got an accelerating skydiver in this part of their journey here. Now you'll notice something interesting here. So you see how the line levels off? The gradient of this velocity time graph is equal to this acceleration. So if we've got no gradient here, we've got no acceleration. We've reached a constant speed. This is a special case. So it's not just constant speed, it's terminal velocity. And it's the maximum speed this skydiver can achieve on this journey, okay? It's a constant speed. We've got no acceleration. Now right here, we've got something interesting happening. This is where the skydiver pulls their parachute. So I'm going to write parachute opens. And you'll notice straight away there's a massive drop in the velocity. So we get a sudden deceleration. Okay, with deceleration meaning a negative or downwards, or backwards acceleration. So this is a slowing down of the skydiver. And here we've got another flat section along here. So we've got a new terminal velocity. Okay, so there's new terminal velocity down here. Now, in order to understand why we get an increasing velocity here, why we get terminal velocity here, a sudden deceleration, and then a new terminal velocity at the end, we need to talk very briefly about the forces acting on this skydiver. So if I start everything over ever so slightly, I'm just going to draw a circle here to represent the skydiver. I'm not going to draw a stick man or anything like that. Now, when he first jumps out of the aeroplane, there is going to be a weight force down, right? Okay. So at this point here, point A, right at the beginning, we're going to have this situation here. So we've got weight, but we've got no upward force at all. There's nothing pushing this skydiver up. So this is an unbalanced force. And because this unbalanced force is acting on the skydiver here, we're going to end up with this acceleration at this part of the graph here. Now, as the skydiver's speed increases, we will see a small amount of air resistance appear. And as he gets faster and faster, we'll get more and more air resistance. And more and more and more and more, until we have an equal air resistance to the weight. So when these two forces, the up and the downward force, when they are balanced, they're equal to each other in opposite directions, we will see here this terminal velocity. So here we have forces balanced. And that's what's special about terminal velocity, that we have balanced forces. When the parachute opens, we'll suddenly get a huge air resistance. Okay, so if you think how big the surface area of that parachute is, it's going to create a really large air resistance force very briefly. And what will that do? Well, we've now got an unbalanced force again, so we're going to get a deceleration. We're going to get a different acceleration here. And that's going to slow down very quickly the skydiver. But think about it. What will happen to the size of the air resistance as they slow down? It will get less and less. So the air resistance gets less and less and less and less and less until once again the air resistance balances the weight and we reach this new terminal velocity down here. I hope that's been useful for you though. Thank you very much.